Mitsubishi Electric began its space venture in the 1960s. Since then, we've expanded our business to include a wide range of activities, producing a range of products from satellite onboard equipment to ground control systems and large-scale telescopes. We took our business overseas in June 2003 with the launch of Optus. We have produced approximately 70 satellites and joined more than 500 programs for satellite components. In 1999, our Kamakura Works, equipped with a satellite production facility, gained a space chamber, a monolithic test facility that can recreate a high-vacuum space environment. In order to optimize quality, tests are repeated consistently from development and design through to assembly in an extreme environment with a 250 degrees Celsius temperature difference. There's now a worldwide demand for satellites to provide high-speed and large-capacity transmissions, which gives everyone easy access to mobile phones and the Internet. To meet those demands, Mitsubishi Electric developed the next-generation satellite platform, which has higher power and uses electric propulsion. Also, it is equipped with more than 100 communication beams, which will cover even the remotest island. Mitsubishi Electric Space Systems business is working on solutions across a wide range of areas, from ground up to outer space. To achieve an even better life for all, we are creating infrastructure for future society through the connection of satellites and on-the-ground equipment. We will continue to contribute to the development of society with its advanced quality and technology.
Welcome back to the APSCC webinar series. I'm Christopher Slaughter, your MC for the series. Today, we're very happy to present the long-awaited webinar on the ETS-9 project from Japan. Joining us today as moderator for the session is a veteran of both these webinars and APSCC and the industry at large, Eddie Kato from Heisei. He'll be moderating the panel discussion, which presents Akira Ogawa from JAXA, for the Japanese Space Agency, who'll be giving a perspective on why the project was commissioned and what the idea behind it was, and what the overall overview of the project. Minoru Ueda-san from Mitsubishi Electric, from Melco, who I'm very happy to also point out is an APSCC board member, and he'll be giving Melco's perspective on this. And finally, the client, the end user part of the equation, is Michiru Nagasawa from Sky Perfect JSAT, who will be talking about what they're planning to do with the satellite once it's up and operational. So again, as I say, long awaited. I know you've been looking forward to it. So have we. Please do enjoy the webinar.
Good morning. This is a panel. We are talking about Japanese engineering test satellite number 9. This is an interesting project in Japan. Government and industry have been jointly working on this project for some time. And we decided to highlight on this project today and listen to the experts to talk about the project and their motivations and background and those kind of things about this project. I believe that this project would be interesting for Asian market, if not today, but in the future. And let's jointly learn about this project and where Japan is going. I have three. By the way, I'm Eddie Kato. I'm sorry to forget about introducing me, but I'm from a company named HISE, my own consulting firm. And I have 3 speakers today from Japan. So we are actually 4 Japanese people, including myself. And it's a little bit feeling bad to talk about the Japanese accents-based English today, by all of us probably, but please bear with us, and we try our best about our speaking in English today for the next 1 hour. How I would do about this panel is to start with three panelists giving presentations to you, each probably about 10 minutes or so, to discuss about their involvements in ETS-9 project first. And then using the remaining time, I would like to have some Q&As and discussions to better clarify about what they're doing, where they're going, kind of things. So first presentation I would like to hear is from JAXA. I have Mr. Ogawa. He's a function manager of ETS-9 project team at JAXA, Japanese National Space Agency. So he would give us a little bit of explanations about his project first. So Ogawa-san, please go ahead.
Thank you, Mr. Kato. As introduced, I'm Akira Ugawa, a function manager, and I'm responsible for satellite system integration and ground system development in JAXA. As this session title is ETS-9 project overview, so let me introduce about what's architecture of satellite systems and the objectives of this satellite project. So ETS is an engineering test satellite series started in 1975, and the latest satellite is ETS-8, which launched in 2006. Through the ETS satellite series, geosatellite and communication technology are always key to develop. So these technologies, I mean the geosatellite platform technology and communication technology advance rapidly, and they can be adopted widely, including communication satellite or GNSS or weather forecast, and sometimes Earth observation satellites in LEO. But they require deep and long-term investment, and this is why JAXA consistently involved or leading these technology development with ETS series. And since we launched the ETS-8, which developed a 3-ton class platform technology and a big deployable antenna for S-band communication, and the WINS high-speed internet satellite in 2008, which demonstrated the high-speed communication technology, including APSS or beam hopping technology. But it's already passed us 15 years since ETS-8 was launched, and it's high time to renew this technology from ETS and WIN to ETS-9 to adapt geosatellite bus and payload technology for HTS for the current trend in the communication market. So we need high throughput and flexible payload for HTS, and all electric satellite bus with enough power, I mean adaptable for 20 kilowatt at maximum to payload, and with 15 years design lifetime for service. And also as a ETS, we also developed GTO and GEO GPSR and a new 6 kilowatt whole cluster for experiments. And with this technology development, we maintain autonomous and strengthen satellite development capability in Japan as a government side. And so our ETS-9 project, it's officially started in 2017 as a joint project based on government reports published previous years, only in Japanese, sorry. But these satellite projects funded jointly by 2 government agencies, MEX and MIC. These agencies are responsible for education and technology development, and other agency, MIC, is responsible for international affairs and communication. And the JAXA is funded by MEX, and Mitsubishi Electric Corporation Merco is awarded as a partner with JAXA. And JAXA defined the ETS-9 bus system and leads to reinforced engineering capability in Japan with outcome. And Merco renews the communication satellite for the commercial market as the outcome of this project. And so JAXA and Merkle will demonstrate high performance all-electric satellite bus. And also we install full digital payload to catch up the current trend of satellite market. And also MLC and NICT demonstrate RF communication technology with digital channelizer and the digital beamforming system. And also NICT will demonstrate optical laser feeder link subsystem, which are high-speed optical feeder link, about 10 Gbps at maximum speed. And also SkyPath JSAT group will offer a satellite platform, and they do their own business with a hosted payload named as GSOM. This is originally JAXA we funded the satellite operation fee only for first 3 years. So to maintain the operation after 4th year, we requested to the public to offer a public hosted payload and to cover the operational fee for the rest of the term for the platform. So we paid for the operation for first 3 years, and SJC will operate our satellite bus. And after that, SJC will operate our satellite system for the commercial service. And they do their own business with GSOM through its lifetime. And this is the very first time for JAXA to accept a hosted payload from a private company for their own business. And this is a new challenge as the Japanese government to form satellite project system. So it's worth for explain what the GSOM is and what SAC will doing for on their own business. So this is the architecture of the satellite project and the objective ETS-9 overview. Thank you.
Thank you. I may have some questions, but I'd like just to keep those to the later stage. And let's listen to some more details about satellite from Merkle. So I have Mr. Ueda. He's a Deputy General Manager of Civil and Commercial Space Department at Mitsubishi Electric Corporation. So Ueda-san, would you go ahead with your presentation then?
Thank you very much, Kato-san. So my name is Ueda, for working for Merkle. So I'm now Deputy General Manager. Actually, I have worked for the our subsidiary in Singapore for 3 years. So I have some experience of the promoting their satellite in the Asian region. So thank you very much. Firstly, I'd like to introduce a little bit of our Merkle space business lineup. We have 4 lineup for spacecraft. So one is telecommunication, which so today's topics. So not only telecommunication, but also we have a business for navigation satellite for positioning. So it's a typical QZSS, quasi-zenith satellite systems. We are planning to launch totally 7 satellites to make the Japanese own navigation network. And also Earth observation, our future for the space business. So radar satellite, optical satellite, based upon the contract with JAXA, we have launched many kind of the Earth observation satellite. So transportation is an unmanned vehicle for the space station. So we are co-working with MHI, Mitsubishi Heavy Industry. We are responsible for providing the electric module for the for H2 transfer vehicle. So below side, we are also having the business for ground station, so such as the TTC, TTC station, and also our unique technology is expanding the telescope for astronomy. So picture shows the ALMA telescope, located in South America, 4,000 meter height of the radio telescope to look for the deep space signals. Now we pick up the Merkle space business. We have started our space business in the 1960s. We have accumulated many development based upon the NASDA, former JAXA, so Japanese program. So the late 1990, so we established our role for the system integrator for Japanese domestic market. And also, so close to 2000, we start expanding the our experience to the global market. So we have established the so our standard platform named DS-2000, which apply to the communication satellite. And we have also accumulated some of experience for global market. Now our expanding to the many kind of the application, not only telecommunication, but also other as observation. So below bottom of the picture, two pictures are concealed. This is the we have supplied the satellite platform for also Ministry of Defense of Japan for the communication purpose. So for expand. So we very significant important roles for the Japanese so infrastructure for the space. So it's my understanding. We highlight for the our history of the communication satellite now. So we have established our standard platform DS-2000 thanks to the JAXA contract, DRTS, data relay satellite testing satellite, and also ETS-9 programs. So due to our experience, we have established our standard platform. So our first satellite for the global market is Optus C1 for Australian regional operator. It is not DS-2000, but it's the first satellite for the international market. Our first satellite with the DS-2000 for communication commercial operator for superbird C2 satellite for launch in 2008, and ST2 and TrueSat 4A and 4B and SL are following after our successfully launched superbird C2. But actually, we have not had the so commercial satellite order for these couple of years due to the so technology innovation is happening, and the market is much more complicated. So that's one solution. The way to resolve these difficulties. ETS-9 program. So it's a very innovational program for the Japanese space market. And also we are very happy to contribute to this program under the contract of JAXA. So we would like to pick up this ETS-9 sheet. So as Oga-san has already explained the ETS-9 program outline, so we just quickly review the so from the point of the so satellite manufacturer. So America has been selected by JAXA for the satellite system provider for engineering test satellite 9 in April 2017. So features of the platform, the communication payload is here. So 25 kilowatt class solar array design, and also all electronics propulsion to increase the satellite payload installation capability is mandatory for the requirement for the recent operators. Also, the another key issue, the so communication payload enable us to provide the fully digital payload. Also, we are now very aggressively developing the so in-house data payload processor with support of the JAXA and the NICT. So we are picking up and scale up this demonstration model to our next generation DS-2000 satellite to the operator. So we now pick up the so few slides for our American next generation. What is American generation satellite for communication? So American new approach for payload and system for here. So is a big capacity and the flexibility. So we are now targeting the high capacity of the satellite 200 gigabps with Ka band is a typical case, but which is having the 100 waves. So it can be applied to the any application of the operator, so broadcast to the point-to-point, and also HTS application. So seamlessly move to the so using the this flexibility satellite. Also, we have to put in the price competitiveness. So it's such kind of discussion never ending to promote the business to the commercial market. So they say typically the target price is $1 million per gigabps, which means so if we sell the 200 gigabps satellite, so satellite cost of the satellite, including launch and insurance, must be less than $200 million. So it's a very good target, but we are now making our best effort to achieve such kind of target. So to achieve this target, we introduced a little bit about the key technology. So there is a payload processor. We are taking the commercial products, commercial components, so FPGA components. So it's completely reprogramming is can be done for in the orbit. That's is a benefit compared to the ASIC components. So we are now having the this the DPP development. Also, we have the we employ the focused array with reflector. So typically, direct reflection antenna, such as APA, active phase array antenna, so can be taken for this kind of application, but for the optimization and the performance and cost point of view, so we have decided to focus array with reflector. So standardization is our common target we must achieve. So one thing I would like the Kamakura Works, our mother factory for the satellite, has established another new factory AIT buildings to enable us to share all information at the AIT phase to all engineers at Kamakura Works simultaneously. That decrease the future abnormal issue and the future in orbit failure. Our satellite can be more qualified, more reliable satellite. We believe this kind of new factory. Okay, so I quickly review this is a general concept of the next generation satellites. So as I mentioned, the typical operator for the utilization of the communication satellite is HTS and also point-to-point, and also broadcast DTH application is a conventional application. All the application can be adapted by our data satellite. So our typical specification is here. So frequency Ka band, but DPP itself accept all the frequencies, not only K band, but also Ku band, X band also. So we are typically, to have the 100 beams and 200 gigabps, so we typically put in the Ka band for the required proposed specification. So we have typically 2 gateways and also the minimum beams size 0.5 degree. Also flexibility means the coverage frequency and power on beams, so can be flexible. One thing I would like to say, so not only digital capability, but also our satellite absorb any other requirement or combination, or not only digital payload requirement, but also the conventional type of the payload. That means we will expand. We have started already some discussion with the operator. So operator, the requirement is very wide, not only a digital satellite, but also some of the conventional satellite. We would like to meet such kind of complicated requirement. Okay, this is a final slide. We put in some examination. So example, for the basic operation for HTS broadcast only. We can change smoothly using our digital payload, and we can satisfy the customers' the requirement. So target schedule is we are now the very important phase for development of the ETS-9. So we hope to start the give the operators some commitment of a payload sometimes in the next year. So we hope to get finally the first Merco satellite digital satellite order by the end of the 2023 or in the beginning of 2024. That is my presentation. Thank you very much.
Thank you, Ueda-san. Before I go to JSAT presentation, for the benefit of audience, I just wanted to have some fact-finding questions to JAXA and Merco about satellite. I might miss some points, but when would the ETS-9 be launched as a plan right now? That's my first question.
Oh, sorry, I missed it to put in my slides. It's planned to launch in the fiscal year of Japan in 2023.
Okay.
23rd.
Okay.
So by the end of March of 2024.
Okay. Yeah, Japanese fiscal year. Okay, so March 24. Okay. And this will be launched by H3 rocket?
Yes, it's planned. Yes, by H3 launcher.
Okay. So, Ogawa-san, may I know then what kind of a capacity you have in a ETS-9 satellite for the payload?
Okay, it's a little bit ambiguous, but it depends on the IT license and the coordination with a ground system, like the size of the dishes or antenna. It's maybe tens gigabps to several gigabps, but it's not a full size of commercial payload.
Okay, well, I understand. Yeah. Okay, thank you very much.
Thank you.
So with that, I think, thank you. With that, I think I'm going to listen to JSAT, Kondosat, or whatever I call type of presentation. So I have Mr. Nagasawa from JSAT, Sky Perfect JSAT, which is, as you may know, they're Japanese and Asia's top operator. And he's program manager for their ETS-9 perspective. So with that, Nagasawa-san, please introduce us about your payload, please.
Thank you, Kato-san, and thank you for the opportunity to give this presentation today. My name is Mitsuru Nagasawa, and I'm in charge of sales for government, including JAXA, and the project manager of ETS-9 project in JSAT. Today, I would like to introduce our activity regarding ETS-9 project. First, this slide shows our business overview. Our business segments are divided into two fields. In our space business, we operate the largest fleet of 70 communication satellites in Asia-Pacific region. From space to the sea, we are creating businesses that take advantage of space assets, including space data. And our company provides Sky Perfect TV, which is the largest pay TV broadcasting services in Japan. We currently have over 3 million subscribers for this service. And we are providing more than 230 channels, including music, sports, entertainment, and so on. This slide shows our geostationary satellite fleet and their orbital slots. JCSat-3A, 4B, and 110A are mainly used for broadcasting, and other satellites are for satellite communications. We have some satellites to own jointly with other companies. Horizon 1, 2, 3E, and JCSat 85 are co-owned with Intelsat. And also, JCSat-110R is co-owned with Broadcasting Satellite System Corporation's BSAT. About HTS, we have two satellites, Horizon 3E and JCSat-18. We are operating HTS satellites to meet increasing demand in the mobility and broadband markets. The last satellites I want to introduce are JCSat-12 and 16. They are backup satellites in case of any accidents in our satellites. This slide shows our ground system for our satellite operations. Yokohama Satellite Control Center is called YSCC as our primary satellite control center. Spaceport East and Spaceport West are served as backup capabilities in case of major disasters or serious system anomalies in YSCC. Spaceport North and Spaceport South are ground stations for LEO satellites. We are expanding our business into LEO market. Next, I will explain one side of activities regarding ETS-9 project. We awarded the contract for ETS-9 satellite TTC operation by JAXA. We have two roles in satellite operations as housekeeping and station keeping. The first role, housekeeping, includes checking out of the conditions and health status of onboard equipment. And also, when we detect some failed equipment on board, we should conduct switching it to the redundant. The second role, station keeping, includes ranging and orbit determinations, maneuver planning, and its execution, and so on. Then, we have to install ground system to operate ETS-9. We have installed many ground systems in the past, and we can achieve to cut the initial cost by own know-how. We will operate ETS-9 in an economically efficient way by utilizing our existing facilities that I shown in my previous slide. We hope that our facilities will be used by other satellites as well. This slide shows the collaboration with JAXA. We have been operating some JAXA GEO satellites, which are WINDS and JDRS, over the decade. ETS-9 will be the third entrusted satellite by JAXA. Here, I'd like to introduce our history of satellite operations. We launched the first satellite named JCSat-1 in 1989. We have been operating more than 34 satellites. Therefore, we have a capability of operating many GEO satellites at the same time safely. And we think that JAXA acknowledges our operation performance. By supporting JAXA's satellite operation, we would like to extend the commercial role and contribute to the space industry development. Last, I will explain about our optical telescope payload. We are planning to embark on optical telescope on ETS-9, imaging the status of geostationary orbit. We want to say in this slide, it is a pleasure that the government provides the opportunity for our hosted payload. Until ETS-8, we understand that the main purpose of ETS-9 series is to develop and demonstrate the space technologies. Now, we are very pleased to see that ETS-9 has added new roles for commercial satellite operators, such as providing opportunities for hosted payloads and satellite operations, in addition to technological development. Hosting a payload with the government enable us to try this challenging mission, which no one has never tried for business. We really appreciate appreciate that the scheme will continue to involve in space-related companies other than manufacturers after ETS-9. This slide shows why we decide to embark our optical telescope payload. In 2021, the number of space objects is about 29,300. Among them, there are about 4,700 satellites in operation. So the rest is space debris. Space debris is becoming imminent threats even in GEO. We believe that monitoring GEO business would have strong future growth potential. We believe that imaging the status of geostationary orbit is extremely important for continuing business in space. As you all know, the distance between the ground and geostationary orbit is 36,000 kilometers. It is very far from ground. Therefore, we believe that we can monitor debris from geostationary orbit. We can get very meaningful results. As a satellite operator, it is our responsibility to maintain the safe space environment. That's why we are trying this challenging mission. The possibility of geo-SSA businesses will be expanding by hosting a geo-monitoring payload such as GSOM onto our geosatellite. That's all. Thank you very much.
Thank you, Nagasawa-san. I had one question taking this opportunity before we leave this chat. So just to clarify, your GSOM payload is monitoring a geo orbit, or it can look down the lower orbit to look at the situation as well? What is your primary purpose?
Now we plan to monitor to geo orbit.
Geo only? Okay.
Yeah. Now we are planning.
So with this payload mission, you look at only geo monitoring?
Yes. Now, actually, it is under considerations, but now we have a plan to monitor only geo orbit.
Okay. I'm just wondering, is this a pure experiment for JSAT, or is this something potentially money-making payload?
Yes, it is for business. So it is for business.
So you are using this opportunity to put this payload, and business goal is to make money from this payload. That's
right. That's right.
Okay. So maybe like government purposes and other means, are they probably source of business potentially? Or commercial?
Actually, we are still understanding consideration, but we hope that this project will be able to contribute to sustainable use of space for all of us. But as for the potential customers who would use these services being under discussion.
Okay.
By side.
Okay. Thank you. All right. I think we have completed 3 presentations, and I was very interested to know about this project a little bit more details through the presentations, because there was a perspective as a government, perspective as a manufacturer, and perspective as a user. So it's an interesting panel to look at those 3 different initiatives in one project. And I think it's very unique attempt, I should say, for Japan to do this kind of thing. That's my first comment. I had a little bit of questions, though, to probably ask anyone who wanna answer. I don't really direct any question to anyone specifically. If anyone wants to speak out, please do so. But my understanding is that JAXA as a government organization, together with other agencies of the government, I believe doing some basic development activities for key technologies. That's what I hear from Ogawa-san. On a bus side by JAXA and maybe payload side by some other agencies. That's what I hear. And Merco as a manufacturing partner to the government agencies is not only manufacturing this satellite, but also for commercializing this technology development in the future by some means. I mean, is that correct understanding, right? And my question is, if in that case, Merco uses ETS-9 satellite as it is, as a commercial product, or you may take, pick and choose some technologies, but you'll go to another product for commercial purposes, or which way you want to go eventually. So I'm trying to ask how this development is materializing as a commercial business. That's my question, actually.
Wilson, can I respond to?
Yes, please.
Can I? Okay. Okay. So as according to this presentation, so ETS-9 purpose is it's not the whole data payload. It's just so small size of the payload, and so purpose is the demonstration and the verification of this technology. So Merco would like to take this verification and qualified technology to the Merco will modify, Merco will add some other function, other payload, so the according to the customer's requirement. And so commercial business is fully Merco's responsibility. And so we are very happy to take this opportunity. So the timing is very important for, so JAXA has considered the key technology is data payload. Merco also at the same time need such kind of the component technology for the customer. So ETS-9 program has started this, so both demand and the desire is fully matched. So that's why the this is my answer. So Kato-san.
Okay. Yeah, sure. So Ueda-san, I have another question for you.
Yeah.
I saw your presentation had a little bit of different configurations, and you said that you were very flexible to accommodate customer requirements.
That's right.
I don't think you can make it. I think to reduce the cost, you cannot listen to customer. That's my theory. You know, if you look at French companies, your competitors, they are basically standardizing the product and not really accepting customers' spec, right? Otherwise, they don't believe that they can reduce the cost. How do you address to that? Are you still trying to accommodate customers' requirements, or you want to go your own way to set your spec by yourself and say, customer, hey, you choose this satellite. If you don't do that, I don't want to sell it.
It's a very difficult to explain, but it's a very key question of this session. But
I think so,
yeah, I think the keyword of this session is for Merco satellite manufacturer is optimization.
Okay.
So we don't take the so we respect the such kind of movement also, like a big European satellite manufacturer is proceeding the standardization, complete standardization for cost reduction. But according to the discussion with the regional operator in Asia, especially in Asia, so some regional operator doesn't want to have the, they appreciate the cost reduction, but they also request some specific requirement. So I think that we are still having a chance to make a business for making a best optimization between the customer requirement and also our manufacturing capability. That's my current position.
Very interesting. Yeah. Okay. If that's the case, maybe you can be unique, right? Because your price may be a little bit higher than competitors, but maybe you are much more adapting what customer wants. That's what you're talking about, right?
Of course, we are our final target is to compete with the European giants to have the standardized, completely software-defined satellite. But we need to have some step-by-step approach here to climb the top of mountain.
Okay. Well, that's an interesting challenge, I guess.
Yeah,
So-
of course, many challenges are necessary for either way.
Yeah, I think unfortunately satellite pricing is going down and down because they need, JSAT like operators need to compete with the terrestrial systems now. And so I see a lot about world movement, like people are struggling how to reduce the cost, right? And what I hear a lot is that by doing the usual cost reduction activities, you can't make it anyway. So you have to have a very drastic, out of common sense type approaches.
Taking this opportunity, I'd like to hear the opinion, frank opinion with from Nagase-san. So which do you want? So just so complete fixed standardized satellite with a very cheap price, or maybe you can be happy to have the some modification or something. So do you have any opinion?
Yes. In my side, in operators, we have to take many aspects into account when choosing our satellite systems, such as our missions, markets, and business scheme. So that if it is very good thing for we can choose the many satellites, including the big satellite and the small satellites and the expensive one or the very cheap one. So we believe this bus system will be best for all of us, including JAXA and Merco and us, I think.
Thank you.
So about the operational side, Nagasawa-san, I think you guys are also procuring a digital satellite as JSAT, right? And what I'm interested in is to know how much you make importance on the payload operation side, like flexibility operations, I should say. Satellite is able to, give a flexibility to operators, right? And the coverage and, frequency, bandwidth selections and kind of things as far as it's fully digital satellite payload, like what ETS-9 is supposed to provide. And in that case, it's a matter of ground operations and ground system and software to manage the capacity traffic. And no matter how flexible it is, you can operate the satellite by your own way and or by your own need. Is that something what you are trying to develop in the JSAT about the HTS operational side, or you are still trying to define the satellite case by case and based upon your service need, you want to have a satellite hardware that adapts your requirements, which is a way that you are trying to do right now?
Okay, that's a good question. Actually, it is not our demand. It is all up to the market we are looking. The change of demand is getting faster and faster. It is important to have a software-defined satellite to satisfy our customers. So
that's a satellite side, right? Yeah.
Yeah, these satellites are very valuable for us.
Yeah. Okay. Yes. True. So, Ogawa-san, is the ETS-9 project including a ground system as well?
Yes, we also have a ground system, of course, to operate satellite system, but we don't develop new satellite operation ground system
Okay.
We just purchase or borrow the satellite operation system from Mercor or SDC.
Okay, so it's not a new ground software to handle the flexible operations in the part of that ETS-9 project yet.
In my side, yeah, but
Okay.
I think MIC may develop a new ground system to match their full data payload, but it's not disclosed well to us yet.
Okay. Okay. I have one question about the platform, by the way. I may be wrong, but looks like it's a huge platform. I think I remember Merco's presentation said a 25 kilowatt bus. That's, I believe, DC power, right? And the payload, you said 20 kilowatts like payload accommodation. So is that something what would be a basis of your future platform product, or you would use element technologies developed by ETS-9 and you would repackage the platform to support your commercial payload model? What is your plan right now?
Ogawa-san, can I respond?
Yes, please. In government side, we don't develop same satellite again. So in government side, we apply the technology developed in the ETS-9 to the government side, maybe.
Understood.
But for the commercial side, please, Ueda-san, respond to the question.
Yes, as a satellite manufacturer, so the development way must be, we have to consider the maximum size we will foresee in the future. That means that it's easy to reduce the capacity from the smaller size, but it's very difficult to from the smaller size to the bigger size. So that's why the 25 kilowatt target the maximum needed satellite power. So like Boeing and the Airbus 700X, maybe a 25 kilowatt also. Actually, we have also.
You're not selling at all.
Yeah, that's why. So we don't fix 25 kilowatt, but DS doesn't originally have the middle size of satellite. So we would like to expand a little bit more about the capability to line up or to respond the various customer requirements. Actually, we have started some discussion with the one operator in the Asia Pacific region to provide the 25 kilowatt satellite. So it was a non-commitment with a fully digital satellite with a no commitment base currently, but we are expecting to realize it in 2024. But that needs is existing, I believe. Thank you.
Well, interesting. I was thinking like a 25 kilowatts is gone from the market, basically.
Basically,
Yeah,
maybe you are right, but
I see all your competitors are going down to a smaller size, like 150 gigabit per second, 12 kilowatt kind of payload as a standard, right? So that was what I was interested, why you chose 25. But, you know, I understand from JAXA's view that you have government roles and industry roles in the one project, so I should really understand that difference.
It's a very complicated point of
a little bit,
It's a new challenge for us too.
Yeah, well, I think it's very interesting challenge, but you know, I think our audiences actually may have a little bit of confusion to understand this, because a simple model is like Europe, like a government pays money and tell industry, hey, you use this to sell it. I mean, that's the traditional model, right? But JAXA's case is a little bit different. You have a little bit more, how can I say, sophisticated way to split the responsibilities between government functions and industry functions. That's how I view from your presentations. That's a interesting challenge, I believe, and it's a lot of work for Merco to commercialize it, I guess. But for our Asian people who are watching this panel, I think they should be able to expect something to come out that may better fit their needs from this initiative. That's what I think this ETS-9 project hopefully would get to eventually, right? So that's I think challenging but interesting challenge, I believe. I think my last question, probably from time standpoint, is how you would view this kind of collaboration between, in this case, JAXA, Merco, and JSAT, and government is coming up with a kind of basic development activities, and given the world trend of technology advancements, and industry come in and work like a partnering, as Ogawa-san presented in your presentation, and of course build a satellite power that development program. However, in the meantime, government, industry will think about the commercialization and always challenge how to deal with the market using the result of development. Now, but government is providing a collaboration opportunity to operator, and in the sense of additional payload, Condosat payload, or operational side. Is this becoming a kind of a standard way gradually in Japan? If I see WINDS and the ETS-8, it looks like, as Nagasawa-san said, you had some collaboration with JAXA from those projects as well. So I'm just wondering that if this is becoming a unique Japan model, so to speak, to work jointly between government and the industry and the operator side. Is there any comment on that?
Okay, from that side, this is a very new model, even for our government to select a commercial company as a partner of the project. But their government law in the space development is already changing gradually. I know in the like SpaceX in the United States, or other companies working hard for space activity without a payment from government. So we have to collaborate more with sharing our role in the space development in the future. So maybe this is a good experiment as a name of ETS, with a structure and responsibility sharing among the government, operator, and the manufacturer. I think it may be a good model, and if this works well, this can be deployed to other projects, I hope.
Great. And I think, Nagasawa-san, from JSAT standpoint, if you have an opportunity to put your payload on someone else's invested project, that's probably good too for you. So maybe this kind of thing is a good potential model for collaboration with government as well, I believe, right?
Yeah, that's right. When it comes to having new and challenging mission like this time, I believe this is one of the best scheme we can develop for both the technological development and marketing, making businesses.
Truly, yeah, okay. And Ueda-san, I think you have a good challenge waiting for you, but I think, again, always government supporting industry is also a good thing as well in many ways. May not be a straightforward way like before, but this is a very good and interesting challenge, isn't it?
Yeah, that's right. Absolutely. So ETS-9 is a very wonderful opportunity for Merco satellite manufacturer. Yeah, we have succeeded to develop the DS-2000 based upon the success of the ETS-8 and the DLTS of JAXA program. But currently, the system is more complicated. So we need to have more communication with the government. And so after the more communication with government, we can achieve some very good programs for ETS-9. So that's a wonderful, taking this wonderful opportunity, we hope to expand our business in the global market. So American position will be a little bit higher than current stage. Thank you.
You should say much higher.
Very, very sincere this time.
Well, I think time is up. And in fact, I had more questions prepared, but I think everyone spoke very well, and I didn't have to use up my questions I prepared. Bottom line is that the ETS-9 is a very interesting experiment for Japan, and it's to me a kind of partnership model by the stakeholders of the country. And it's not simply looking at government putting money in to commercialize it. It's a challenge. But it's a good challenge, I believe, and beneficiaries are, of course, end of the day, Asian operators and customers as part of the community. So let's keep looking at how this project goes and how something come out from this attempt to be something meaningful for a commercial operators and commercial market to tag on. So that's my conclusion. With that, I would very much appreciate the three of you. Thank you very much for your participation today. And it was, of course, much easier for me to speak in Japanese. After living in US for 30 years, still Japanese is better than English. So I'm sorry that my moderation was not really smooth, but I enjoyed a lot about talking to you guys. Thank you very much. And also people who are watching this panel, thank you very much for watching. And let's keep eyes on this project. Probably a couple of years later, there will be a big stake to be coming out from this attempt. Thank you very much. So long.
Thank you.
Thank you.
Thank you very much.
Thank you very much.
Thank you very much, Eddie. Thank you very much, Ueda-san. Thank you, Nagasawa-san. Thank you, Ogawa-san. But also thank you very much to Melco for providing support for today's webinar series. As we say, it's been a long time coming, and I think that it was very informative and very useful. So thank you all very much for participating and for being part of the webinar series. And thank you for watching today's webinar. Thank you for watching all of our webinar series. You've made the series a tremendous success. Please do continue to join us for upcoming webinars. If you want to know more, you can check on this website, apsccsat.com. If you look up along the top, we've got listings for upcoming webinars. If you're interested in participating in a webinar, if you're interested in sponsoring a webinar, if you have ideas for topics you'd like to see, please do get in touch with us. You can send us an email at info.apscc.or.kr. That's a long-ish sort of web address, but if you just send an email to us there or check us out at apscc.or.kr, the main website for the association, we'll be happy to enter into a discussion with you about what we should be doing going forward. Once again, thank you so much. We look forward to seeing you here again on the next installment of the APSCC webinar series. Have a good day.